Hello, good evening. Hello, good evening. Am I audible?
Yes, sir.
Yeah, yeah, okay, fine. Let's get started. All right. Okay, guys. So, for the past few weeks, we hovered over a lot of topics. Especially, we started with the ducting side, and down the line, we learned about the duct routing concepts, and similarly, we learned that duct sheet metal quantity survey. And likewise, the fan selection topics, piping knowledge, and us the secondary pipe sizing, and the and further, yeah, we studied about the pump selection topic, isn't it? So let's continue the pump selection topic. Why? Because we just hold it over to this fitting head loss, isn't it? So I will give a small recall about what we done in the past few days. All right. So actually, this is our project. Yeah, so this is our project was, and the purpose of doing this project to find out the actual HP of this primary pump sets. In order to know the HP of this primary pump, I need to find out the head value. That means the maximum distance of the piping. So probably it should be from the farthest chiller to the farthest air handling unit. And we considered our flow path according to these constraints. Delicately, we found out the actual head loss caused in those flow path pipes itself, isn't it? Which means among these flow path, we considered the entire head losses, which is meant to be the frictional loss. So we know that if there is a frictional loss, probably it will affect the flow of water, isn't it? So initially we are going to finding out the actual head loss with the help of some constraints, with the help of this pipe size or either by the graph method, whatever, you'll be getting those values. And initially we started with finding out the head loss of straight pipes. Down the line, we just uh, bumped up into fitting loss, especially those elbows, reducers, T-junctions, isn't it? Next of all, we are going to start about the accessory loss. That means, among these connections, there are different kind of accessories will be there. So in this calculation, we will be preferentially going over to the accessories which comes across our equipments itself. For that one, I'm going to show a small example right here itself. Here you can see for a pump, you'll be having two butterfly valves, one for inlet, another for the outlet, isn't it? And same for the chiller itself, like one for inlet and the other one for outlet. And for AHU, you know, inlet and outlet, you'll be having two number of like for inlet and outlet, probably you'll be having a butterfly valve. Beyond that, for the modulating valve, you know, we can see this three butterfly valves right here itself, isn't it? So these three butterfly valves. So including this three butterfly valve right on the AHU, you will be having approximately five number of butterfly valves in per AHU itself. So that's what they mentioned here. It has to be five. And similarly, balancing valve. We know that a pump doesn't need a balancing valve because it should be a fixed probable flow right there itself. But as in the case of chillers and AHU, we need to uh, constrain or we need to balance those flow or adjust those flows with the help of this balancing valve. That's why you'll be having one number of balancing valve right on in chiller and AHU. Okay. Then let's consider about this NRV, which means the non-return valve. We studied that it should be implemented on the outlet of each and every pump sets or each and every pumps. Why? Because it will hinder the reverse flow, isn't it? So the only equipment which comes across in a pump, it should be NRV itself. And chiller and AHU doesn't need this kind of NRVs. Whereas in the case of strainers, we can prefer it for either pump, AHU, even for chillers. But here it doesn't consider chiller. Why? Because you know that the same water should be comes from these air handling units. It'll be again supplied over to the chiller itself. So that's why inside the chiller you also having a strainer. So you don't need a strainer right on the chiller. If you place a chill, if you place a strainer right on into a chiller inlet, should be a good thing, not a problem too. But here they doesn't consider. And we studied about the modulating valves. Modulating valves are always placed at air handling units, isn't it? That's why we can see one number of modulating valve right on the AHU. So let's consider this scenario according to our aspect. That means for our project, by considering our flow path, this is the first issue that I need to consider, isn't it? So let's start with the butterfly valve right here itself. For pumps and for pump sets, which means, initially you'll be having a pump, isn't it? For a single pump, what should be the probable number of butterfly valves? That should be two. So for that one, you need to uh, remark the data of the pump sets, especially it's about the capacity. We know that each and every pump right inside the project will allow only 70-ton capacity of water. That means around like 168 GPM, isn't it? And we know the pipe size, it has to be 3 inches. Why? Because we already found out the pipe size respectively in the previous calculations itself, isn't it? That's why. And now it's about the length. So I told you that, guys, for fittings and similarly for accessories, there won't be any kind of lengths. Here, the losses are expressed in equivalent feet of length. That means the losses of that equipment or fittings should be expressed in the length value itself. Okay. So how to take out the value? So that's one. You need to get over with something called as to be like this. So here we can see valve losses in equivalent feet of pipe. And among this chart, we can see a lot of accessories are there, like globe, 60-degree wide, 45-degree wide, angle, gate valve, swing check valve, white tape strainers, lift check valve. So a lot of valves are there. Here we are considering butterfly valve. So respectively for butterfly valve, you need to get over with the gate valve assembly right here itself. Okay, and we know the pipe size for that specific pump. That means for 168 GPM flow rate at a certain velocity, we got the pipe size has to be 3 inches. So for 3 inches, which represents, you need to take out for the 3 inches. And here you can see for gate valve, it's like 3.2, isn't it? For a single gate valve of 3 inches size, the equivalent length of that accessory should be around like 3.2. So that's it. Now, you obviously know the actual head loss. So this is meant to be the actual head loss. I told you guys, actual head loss always depends according to the flow rate and velocity. So it should be already you gotten from your previous calculation right here itself. For 70-ton capacity, the head loss is 6.47. So that's what I'm going to mention right here itself. At the end of the calculation, 6.47 divided by 100 into equivalent length, that is 3.2 into 2 number of butterfly valve for a single pump, isn't it? So that's what I'm mentioning. It has to be 2 right here itself. And it's around like 0.41 feet of water column. So that's what we got for a single pump assembly right here itself, especially for a butterfly valve. Satisfactorily, you need to continue the same calculation for chiller and AHU. So here, the chiller which having the same spec according to the pump itself. What I'm saying is the chiller also allows 168 GPM amount of water itself. Why? Because it's a 70-ton capacity chiller, isn't it? So obviously, here the pipe size is same and the equivalent length is same, and even the head loss is also same. That's why here you can see it has to be 0.41. So while considering chiller, once again, you need to multiply with 2, which means, number of butterfly valves. Next of all, it's about the age. So
So
according
here in the butterfly valve is mentioned as 1 in the Excel sheet for pump.
Sorry,
One
what
in
the
இருக்குங்க sir.
pump?
Left side butterfly valve.
It's two right here.
Here,
It's this
here in the first A
this
column.
one, huh?
ஆமா sir.
That's a serial number, bro. That's it. This one I'm saying, isn't it? That's a serial number. 1, 2, 3. That's it.
Okay, okay. Sorry, confused.
Serial number. Yeah,
Okay.
not a problem. Fine. All right. So according to our flow path, the only AHU that I'm going to consider is the farthest one. This is meant to be this 40-ton AHU. So for 40-ton AHU, you know, the flow rate is 96 GPM, and for 96, and the pipe size is 2.5 inches. So respectively, for 2.5 inches pipe size, the value is 2.8, isn't it? That means 2.8 feet of water. So that is the value directly. Sorry, this is a 2.8 feet. Then once again, you will be getting the actual head loss from the previous columns. Okay, now then multiply those value right here itself. And while considering for AHU, you need to consider it has to be fine number of butterfly valves. Okay, now so that's it. You'll be getting the actual head loss. Sorry, the total head loss for that butterfly valve right there itself. Now it's about the balancing valve. So as in the case of balancing valve, that means it's a flow controlling valve. So among this chart, you need to take the globe valve consideration. Generally, in this globe valve, these are the mainstream ones, like 60° and 45°. But here I'm going with the base value with the globe valve right here itself. That means you can adjust the flow. That's what I'm saying. Okay, now. So once again, guys, here, where else you having this balancing valve? Expect pump, you'll be having balancing valve both in chillers and AHU itself, isn't it? Once again, you need to enter those values like chiller, flow rates, pipe sizes, actual head loss. The only value you need to find out from the chart, it's the length. And I know the pipe size of the specific line right there itself. For in the case of chiller, for 160 GPM, the pipe size is 3 inches. So 3 inches, which means you can see for global, it's like 84. And for AHU, the pipe size is 2.5 inches, isn't it? That means it's here you can see the value 69. Okay, now. So that this is how you need to get over those values. Once you got the value, multiply with the number of accessory, which means the number of balancing valve that you will be having right inside the arrangements. That's it. You'll be getting the actual value. Then later it's about the NRV, which is non-return valve. For non-return valve, you need to consider this one. Here you can see two kind of things are there, like swing check valve and lift check valve. So normally you can consider swing check valve for right here itself. Okay, now. And respectively, the NRV will be always placed on the outlet of pump and nothing else, which means the AHU and chiller is not required or not equipped with this kind of NRV connections. So basically, for pump set, the flow rate is 160 GPM and the pipe size is 3 inches. That means once again, the value for the swing check valve is around like 30. Okay, that's it. Now you got the value. Then the other constraints are same, guys. Later, it's about the strainers. Normally, we will be considering white type strainer, and two strainers are there, like flanged end strainer and screwed end strainer. You need to consider flanged end. Why? Because this is the easiest connection that we can attach onto the chiller lines itself for easy maintenance. That's it. Then strainers are placed in AHUs and pump sets. So that means for 72 capacity and 40 capacity. So here it's not meant to be the capacity, guys. It is meant to be the flow rates. So that's what you need to consider. Okay. So acceptably here for pump set and AHU, you will be getting the respective values. And in order to get those equivalent length, once again, it's up to the pipe size for 3 inch and 2.5 inches. That means 42 feet and 28 feet. That's it. You got the value. Then later, it's about the modulating valve. Generally, in this project, I told you this is an air-cooled chiller with primary pump set assembly only. So probably here you will be having a three-way modulating valve, isn't it? You'll be having a three-way modulating valve. For a three-way modulating valve, it should be what I'm trying to say here itself. The working of that three-way modulating valve should be probably, let's have a complex structure. That means the head loss also should be comparatively high. That's why here For a modulating valve, the equivalent length is directly mentioned as to be 100 feet itself. All right. Or in other words, whatever value you will be getting right there itself. For example, here you can see here the actual head loss value 6.68. That means 6.68 divided by 100 into 100. That means, the equivalent length. You will be getting the same value. That means the direct head loss. Oh, so satisfactorily, we got the whole accessories loss. Now add it up, which means add the entire values. Okay, now. So here I added the entire values. Later, it's about the equipment loss. So here you can see pipe total head loss, which means I've been considered. That means I just added the entire head loss from the straight pipes, fitting losses, accessories loss. That's it. I considered whole values. Okay, now, and that's what I mentioned here. It has to be pipe total head loss. Besides that, so guys, just make a quick recall what we are actually doing right here itself. To know the pressure drop and frictional loss, then only the water can flow across the entire system, isn't it? One second, guys. Okay, so here the equipment losses should be considered. That means we initially started with the pipe losses. That means, the water will be flowing across this pipe. Down the line, these same water should be carried across these fittings, accessories, isn't it? At the same time, that it should be terminated either to the chiller, AHU pumps. So they having contradictorily lot of contact across these equipments. So while flowing into those equipments, in that area, you will be having a small pressure drop now. That's also we need to consider. So that is meant to be the equipment loss. So respectively for equipment loss, we can see chiller, shell and tube heat exchanger loss. Okay, chiller, shell and tube heat exchanger loss. That means what? After the water should be carried over from this respective air handling units, it should be again terminated into those chiller itself, isn't it? Inside the chiller, you will be having these tube arrangements. So probably the water should be carried across this tube, should be flowing across the tubes, isn't it? So these tubes can cause some kind of pressure drop. That means frictional loss. So generally, those values are respectively mentioned right here itself. You can see chiller shell and tube heat exchanger loss. That's around like 15 feet of water column. And the same concept on the AHU itself, which is meant to be the cooling coil. So AHU cooling coil loss, that's around like 10 feet of water column. Down the line, you can see the pump impeller loss. What do you mean by pump impeller loss? As if the water sucked by the suction side of a pump, it should be directly contacting with the impeller blades. So as if the blade started to hitting this water, it creates some kind of friction. So these are the values for each equipment aspects. So you can see for chiller, it's like 15 feet of water column. Actually, it's not a constant value. It will definitely changes. Then AHU cooling coil loss, that's like 10 feet of water column. Then pump impeller loss, that's around like 5 feet of water column. So once you added these values, now add up this equipment loss with the total pipe loss, which will give you around like 109.02. Okay. Here you can see this now. All right, guys. So now we got a value around like 109 feet of water column. Then you must need to consider a 15 to 20% of factor of safety. So what is the purpose of factor of safety? Which means in future there is extra more fittings are added right inside to the circuit itself, or some kind of accessories are changed. So that's why we are considering this factor of safety value. And by considering those factor of safety value, you need to consider, sorry, you need to add up the remaining value, which means the actual head loss, which is the actual total head loss value, and the factor of safety value, which will gives across 130 feet of water column. That's it. Now we got the actual head distance that we will be requiring. So this means we need to propel this water approximately 130 feet of water column. Okay, now that means I need to ship down this water 130 feet distance to reach the primary pump. So if I'm implementing a pump, the pump have the capacity or the ability to draw the water against this 130 feet. All right. So that is the concept. Now, let's talk about the BHP calculation. Head is not the exact aspect that we need to consider. Rather than we need to find out the HP of the machine. So as in the case of HP, the equation stands for flow rate into head loss divided by 3960 into efficiency. What is the flow rate here itself? For a single pump, it will only carry 168 GPM. That means 7010, isn't it? So 168 into head loss, which is this 130 feet of water column, and whole divided by 3960 into efficiency. So here I considered the efficiency around like 75%. Generally, it should be like 70% to 85%. That's what we are generally considering. Now we can see I got the BHP value. So what I'm trying to say right here itself, 168 GPM into total head loss. This is 130 and divided by 3960 into efficiency 0.7 will give you around like 3.8, isn't it? Second, I need to throw those bracket, otherwise it should change. Okay, now, yeah. So now you can see the HP that we got, it's around like 7.9, isn't it? How much we got? 7.92. Now, you need to consider the motor driving loss. You know that obviously these pumps are operated by these motors itself. So we need to consider the motor driving loss. All right, so the driving loss here I consider it has to be 10%. That means into 10% value. Okay, so that's like 0.79. Then add up this both values. That's like 8.72. So approximately I need a 9 HP motor right inside the project itself. That means once again, for a single pump assembly, I need 9 HP machine. Okay. Or in other words, for the single pump, the capacity of that pump should be around like 9 HP. Similarly, I need to place 9 HP machine of 3 nozzles, which means two 9 HP will be working and the other 9 HP will be on the standby mode itself. Okay, I'm not saying total it's like 9 into 3. Okay, I'm simply saying each pump have an HP of 9. That's it. Suppose if it is a water cool chiller and you need to find out the actual uh, HP of the secondary pump also, you can do the same calculation, which means respectively, here we considered the supply and return scenario itself, isn't it? But if you're having the secondary pump, you don't need to consider the return scenario. That means among the straight pipe head loss, we just added the supply and return head losses, isn't it? Instead of that, you can add up the entire value. That's it. And once you get over with the actual HP of this machine, you can see this around like 8.9 HP. Now this 9 HP should be similarly applied for the secondary pump assembly also. But for in their case, these 9 HP pump should be in a VSD spec itself, which means it's a variable speed driven motors. And once again, normally these kind of pumps are called as to the split case pump. So what do you mean by split case pumps? Generally, split case pumps, which means the motor should be packed distance from those of the impeller itself. That here you can see some arrangements. Yeah, this one you can see this now. Actually, this is a multi-case split pumps. The motor is placed right here itself, and this is the impeller side. So the aspect of these kind of split case concepts, it's very simple. It is used in order to restrict the heat transfer from the motor right on to the fluid itself. Okay, now that's why we are using this split case concept. So normally these split case pumps are used in HVAC, firefighting, plumbing also. Okay, now. So I hope you got the idea. So is there any doubts on the secondary pump calculation, guys?
Sir, to brief in short, based on tonnage வச்சு pipe length flow rate வச்சு we are finding the HP of the pump. அப்படிதானே
Yeah,
sir?
once again, one more thing.
இந்த
It's not meant to
sorry.
be, yeah, basically it is meant to be the length, not the length, okay. It's simply the distance of the piping. So எவ்வளவு தூரத்துக்கு பைப்பிங் போட்டிருக்கீங்க அதுக்கேற்ற மாதிரியே தான் உங்களுக்கு ஹெச்பி வரும். ஓகேங்களா? ஒரு 10 மாடி பில்டிங்கா இருந்தாலும் 15 மாடி பில்டிங் இப்ப நம்ம எடுக்கிறது ரொம்ப டீடைலிங்கா எடுத்துட்டு இருக்கோம். Actually, for an instant calculation, we can simply get over the vertical height of the building and the horizontal extreme of the building, which means இப்போ for example 100 cross 70 இதான் ஒரு per square, sorry, ஒரு per floor உடைய ஏரியா எவ்வளவுதான்னா you need to consider that 100 which is meant to be the horizontal extreme length, isn't it? அதுவும் அந்த பில்டிங் உடைய vertical lengthம் டைரக்டா எடுத்தா மட்டும் போதும் நீங்க, like which means that is the farthest distance. அப்படிதானே? இப்போ ஒரு 200 அடி போகுதுன்னா ரூம்ல ஒரு 50 அடி இங்கிட்டு போகுதுன்னா எக்ஸ்ட்ரீம் எண்ட் 50யும் வெர்டிக்கல் எண்ட் 200 வரும். அப்படித்தானே? சொல்றது புரியுதா உங்களுக்கு?
ஆமா சார்.
அதுதான். அப்போ அப்படி எடுத்தாலும் ஓகே. தட் மீன்ஸ் இவ்வளவுதான். இப்ப நம்ம now we just precisely calculated how much water should be propelled against the head loss. So அந்த head loss தான் நம்ம இப்ப கண்டுபிடிச்சோம். புரியுதா உங்களுக்கு? இது கொஞ்சம் கூட precise calculation. That's it. So I hope you all got this point.
ஹெட் லாஸ்க்கு வந்து இந்த டன்னேஜ் வந்து எங்க இருந்து 168 GPM came from, அது எங்க இருந்து where did we derive that from, sir?
From, we studied that now for a single pump it only carries 70 ton, isn't it? 70
Single
into
pump of
2.4
what capacity?
2.4 GPM, that is 168 GPM, for closed
Single
piping
pump,
system. Remember or you forgot?
Actually I forgot, I think so.
Yeah, that's
Single
it.
pump na pump capacity என்ன சார் அதோட? Like அது
Pump
லாஸ்டா தான
capacity தான் இப்ப நீங்க கண்டுபிடிச்சீங்க 9 HP.
ஆமா சார், இப்ப கண்டுபிடிச்சோம். அப்போ சிங்கிள் பம்ப்னா எனி பம்போட இது
அதான் இந்த ஒவ்வொரு
168 GPM.
பம்புக்கும் 9 HP நீங்க வைக்கணும்னு சொல்றேன். இது 9 HP, இது 9 HP, இது 9 HP. புரியுதா?
அது அது புரிஞ்சிருச்சு சார். அது லாஸ்டா தான் நம்ம கண்டுபிடிச்சோம்.
ஆமா.
ஆனா ஸ்டார்டிங்ல 168 GPM எப்படி எதை வச்சு கண்டுபிடிச்சோம்?
That's it. Okay. So just look right here itself. Here, what is the total capacity? Tell me.
70 ton chiller.
No, 140 ton chiller. That is the total capacity.
140 ton chiller.
But individually, they split it up into two different chillers, which carries 70 ton capacity. Isn't it?
Okay.
So
Yes.
likely wise, இதை பேஸ் பண்ணி இவங்க பிரைமரி பம்ப் செட்டையும் அரேஞ்ச் பண்ணிருக்காங்க. That means for one chiller will be having one pump, another chiller will be having other pump. But however, here we consider the entire head loss for a single pump. அப்படிதானே? மொத்த ஹெட் லாஸையும் வெறும் பம்பு கொடுத்த மாதிரி எடுத்துருக்கிறோம். நல்ல விஷயம் தான். ஹெச்பி அதிகமா கிடைச்சிருச்சா, மிஷின் நல்லா ஓடுமா அங்கிட்டு ஒரு 5 10 வருஷத்துக்கு. That is the concept of this. Okay, clear? இப்ப புரிஞ்சுதா? Actually, it's not the exact concept, guys. Why? Because here I just randomly said it has to be 140, but in the real life projects, the flow rates are different. That should be easily calculated according to the chiller concept itself. Okay, for each pumps there should be an allocated flow rates will be there. It's already should be mentioned like 200 lph, 500 lph. That's, we can convert that into GPM itself. It's your spec. That's it. Okay, so let's jump over to the next topic. We can go. Okay, now can we go? So is the secondary pump selection is clear? Because I'm going to turn off this CAD point.
Yes, clear.
Okay, fine. For others like Shafiq, Shahul, Nuster is a man. Yeah, sorry. Yeah, Avinash, all good na? Shahul. And okay. മാമിന് മനസ്സിലായോ? ടച്ച് വിട്ടുപോയോ? അവിനാശേ മനസ്സിലാവുന്നുണ്ടോ ക്ലാസ്? ഓക്കെ, ഫൈൻ. Okay. So okay, Shah. Okay, fine. Okay, guys, now we are concluding the whole. So once again, guys, in the last class I explained you how to take out the cooling tower water quantity. Just go through that video. I'm not going to repeat again, but that's an important topic. Okay, now, so in the last previous 2 sessions I just explained how to find out the cooling tower concepts. It's very simple. For 1 ton, the equivalent water capacity is around like 3 GPM to 4 GPM. So you can directly calculate it according to the chiller. Okay, now that's it. So don't forget that stuff also. Okay, now we are jumping over to the last of our HVAC sessions, especially the first, sorry, the last time, but at least the topic which is meant to be ventilation. Okay, so we already completed a lot of topics regarding with the ventilation as well. Lot of we considered a lot of ventilation aspects. So especially among these ventilations, ventilation. So we studied about the ventilation. What do you mean by ventilation? Ventilation is a process where stale air is removed and it should be replaced with fresh air, isn't it? This is what we studied in the primary sessions itself. Am I right? So once again, you can get a small recall about this stuff. Ventilation is the process of removing stale air and replacing with fresh air. So it is done for mainly three purposes, that's for oxygen replenishment and odor removal and toxic gas removal. All right, guys. So in the starting session, I explained that there are two kind of aspects are there, like positive ventilation and negative ventilation. As in the case of positive ventilation, we will be using some kind of uh, what is that was? Yeah, you will be having a fan, and this fan will use to draw the atmospheric air, and it should be forced right onto the room itself. So, and I explain one more thing. This is meant to be, or this is used for human comfort application, or in other words, air conditioning process. So most of the air conditioning process, which refers to positive ventilation itself, isn't it? Once again, as in the case of negative ventilation, we explained that with the help of a fan, we will be removing the air and gradually the atmospheric air will balance out, isn't it? That's what we studied in the case of negative ventilation. So while comparing this with positive ventilation with negative ventilation, positive ventilation, which refers to the air conditioning aspects, and once again, it's preferentially gives some importance to the fresh air itself. So how to calculate the fresh air? The basic three steps to find out fresh air, which is FACFM. What was it is? You know it? What is it? Tell me, guys. CFM per person
Fresh
method.
air CFM per person.
Exactly. ACPH method. And
ACP. Okay.
one more thing will be there, which is CFM per square feet method. But however, we will be considered the CFM per person method and ACPH method to find out the actual fresh air quantity required in each rooms according to the occupancy, isn't it? So once you got these values, you need to add up the sum total. For example, for each rooms, you will be having a certain amount of fresh air requirement. What I'm saying is, if you having a project like theorem for manager cabin, you need to provide 50 fresh air CFM. As in the case of office area, you need to provide 500, 400 FA CFM. So where are you getting these values? You need to consider that area and you need to do the calculation like CFM per person method or from the ACPH method, whatever the value you'll be getting, which is higher, you need to consider it has to be the FACFM value, isn't it? So down the line, uh, once you got this entire FACFM values, you need to add up the value, which means individually that we done now. Like for example, like manager cabin 60 FACFM, chairman cabin 100 FACFM. You need to add up those whole values, and you will end up with a bulk value like 3000 FACFM. So that is the capacity of the fresh air mission. So we will learn about the fresh air mission, which is TFA, treated fresh air unit. Okay, now. So normally these TFAs are implemented to provide fresh air. Directly, it will supply the fresh air across the rooms on a temperature according to the comfort temperatures. The comfort temperature is it. That's it. So how to size the duct? The velocity of fresh air duct with fan, it should be the same spec itself, like around like 1000 FPM. So you know that one. Q equal to AV. If the Q value is 3000 FACFM and the velocity is 1000 FACFM, you got the area value, like 3000 divided by 1000, which means Q by V, isn't it? So 3000 divided by 1000, which means how much you got? Tell me, guys. I don't know. 3000 divided by 1000.
3.
I don't know. Okay, so that means 3 square feet, isn't it? So 3 square feet, that means now we got the value in square feet. Actually, you know the height of the duct, which is according to the planar area aspect, isn't it? So 3 into 144, like 432. For example, if the duct height is 14 inches, you got the area value, isn't it? Divide the value with the height itself, which means 432 divided by 14, which is approximately like 30.8. That means 32 inches. So 32 cross 14 is the size of the main duct for the fresh air ducting. All right. Is it clear?
சார் இது ஒன்லி சென்ட்ரலைஸ்டுக்கு மட்டும்ங்களா
No,
இந்த
it's
ஃப்ரெஷ்
not
ஏர்
meant to be centralized. It's for fresh air system ducting. Okay.
அதான் சார் ஸ்ப்ளிட் யூனிட்ஸ் ஓகே
No,
சாரி
no, no,
ஒன்லி
no.
ஃபார்
There is no fresh air provision for split units.
எஸ் எஸ் எஸ்
Once
ஓகே
again,
ஓகே
guys, ஹலோ நான் இங்க சொல்றது வந்து நம்மளுடைய ஆக்சுவல் ஏர் கண்டிஷனிங் மிஷின்ஸை பத்தி கிடையாது. தெர் இஸ் அ மிஷின் கால்ட் டிஎஃப்ஏ, ட்ரீட்டட் ஃப்ரெஷ் ஏர் யூனிட். அப்ப இந்த இதோடைய வேலை என்னன்னா டிரெக்டா அட்மாஸ்பியர்ல இந்த ஏர் எடுத்து ரூமுக்குள்ள விடுறது. அப்போ அதுல டக்ட் அட்டாச் பண்ணிருப்பாங்க. அந்த டக்டோடைய சைசிங் கண்டுபிடிக்கிறதுக்காக தான் இந்த ஒரு கான்செப்ட் நான் இப்ப சொன்னேன் உங்கள்கிட்ட. புரியுதா? ஓகே.
புரியுதுங்க சார் இது சென்ட்ரலைஸ்டுக்கு மட்டும் தானே சார் இது ஃப்ரெஷ் ஏர் யூஸ் பண்ணுவோம் நார்மலி
நோ நோ நோ,
நான்
இட்ஸ் நாட்.
சென்ட்ரலைஸ்ட்
ஏன்னா ஆக்சுவலி நான் சென்ட்ரலைஸ் தேவை கிடையாதுன்னு இல்ல.
தேவை கிடையாது
No,
ப்ரொவிஷனும்
obviously.
கிடையாது
If, for example, if you're having a high wall easy and if you need fresh air, you can take it tap out from the fresh air duct also. That's not a problem. Okay, clear.
ஓகே சார் ஓகே 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 தட் கேன் பி டன் இஃப்
That
ரிக்வயர்ட்
means
பண்ணிக்கலாமே
if it required, you can provide the supply air or even fresh air also you can allow. Okay, what I'm trying to say here itself, there should be two number of ductings will be there. Supply duct also will be there and fresh air ducting also will be there. Okay, now you get my point. You will learn this one in the upcoming session. Okay, clear.
ஓகே ஓகே
So whatever, that is the concept
ஒன்
of.
மோர் திங் இந்த ஏசி பிளேஸ் பண்றாங்களா சார்
ஆமா,
ஆப்போசிட் டைரக்ஷன் அது வந்து நம்ம எப்போ பார்ப்போம் இந்த செஷன்
எந்த
லைக் ஒரு
எந்த
ரூம்ல
ஏசி புரியல.
இப்போ ஒரு லார்ஜ் ஏரியால ஒரு 4 ஸ்பிளிட் ஏசி போடுறாங்கன்னா ஹவு டு பிளேஸ் இப்போ ஆப்போசிட்டா
The
சைடா
in
அந்த
between distances should be probably equal. You must need to assure that the each and every airflow is entering on the center portion. Okay, not in the corridors. You getting my point?
அது
It shouldn't be stacked up onto the corridors itself. So probably you need to maintain that's according to the site aspect itself. It's according to the room space itself. Okay, now
எனி மெஷர்மெண்ட் ஆர் கால்குலேஷன் ஆர் எனிதிங்
it's very
அந்த மாதிரி
simple.
இந்த
It's according to the no, there is no measurement for that in my. Actually, it's up to the fan throw length itself and according to the capacity of the fan. Normally, a fan can throw up to 10 to 15 feet, okay, now from a high wall
ஓகே
split
சார்
AC. So that means you need to arrange those machines according to that aspect itself. If you are placing or
ஓகே
if you are going with this kind of high wall aspect, otherwise we can simply go with it's within an office area probably. There is no need of high wall AC, isn't it? We can simply go with
எஸ்
those diffusers concept itself.
எஸ் எஸ்
If you
ஆமாம்
need
சார்
separate controlling, you can provide a VAV. So we can learn that about VAV later in the class itself. So guys,
ஓகே
that's
சார்
all about the concept of this positive ventilation. Now let's discuss about the negative ventilation. So in negative ventilation, we studied that here we are removing the stale air and gradually the atmosphere air will balance out, isn't it? That means it will allow the remaining fresh air directly onto the rooms itself. But for that stuff, we need to find out the actual fresh air CFM required for those areas. So this is not meant to be the rooms or anything. It's purely meant to be toilet area and similarly underground, like the tunnels, basements, car parking areas, and probably the factories. So these are meant to be, or these are meant to be the consideration comes inside the negative ventilation aspect itself. Okay. So for negative ventilation, how to calculate the fresh air CFM? For this one, there is the only one method that we will be following. It's the ACPH method. That means you know the equation, ACPH into volume divided by 60. So how we got this ACPH values? So in while doing some project like Mauryan theorem, you've been seeing some sort of value consideration, like consider one ACPH FA, consider one ACPH fresh air, isn't it? That you've been seeing this one. So normally these fresh air ACPH values are mentioned in these ASHRAE 62.1 and 62.2 standards. So that's how you got those ACPH value for each occupancies. Okay. So once again, here we will be discussing the negative ventilation aspect itself. That means for especially this toilet area, kitchen, factories, likewise. All right. So fair enough. Here, let's start with the negative ventilation itself with restroom ventilation. So in here also, you need to consider two different aspects, such as to be domestic restrooms and commercial restrooms. So what is the difference between domestic restrooms and commercial restrooms? It's to the occupancy and the usage of or the frequency of usage of those restrooms itself. For example, in a domestic restroom, as an office person, you know the idea, isn't it? Initially, we will be using the restroom for probably in the morning, and the remaining time will be in the office itself. So mostly we will be using the office restrooms itself. Will not return to our home for the other purpose itself, isn't it? So normally this is the concept. So that's why for domestic restrooms, we can simply adopt a simple exhaust axial fan assembly. So this is meant to be the simple exhaust axial fan assembly right here itself. Like a normal axial fan arrangement, like a propeller type fan arrangement. Okay, but here this is not the concept. First of all, what type of equipment or measurement that measures that you are going to take out the ventilation process right there itself. For especially for domestic rooms, sorry, domestic restrooms, we can get over with a simple exhaust axial fan. Now it's about the calculation. So I told you, in order to find out the fresh air CFM, you need to consider the area constraint only. There is no according to the occupancy, isn't it? But because the persons will not be occupied right inside the area for long term, isn't it? That's why the only aspect that we need to consider, it is not CFM per person method. Instead of that, we will be going with this ACPH method itself. So you know the equation ACPH into volume divided by 60. What do you mean by volume? Volume is nothing but that is the room space. That means the toilet area. Length into breadth, which means the area into BOS. You can simply state like that. So area into height. That's it. We got the value. And after that, here is the main concept. It's about the ACPH. So how to calculate the ACPH? So the ACPH value lies in between for the domestic restrooms around like 5 to 10. Okay, what is the value, guys? 5 to 10. For example, if the room area is 500 square feet, sorry, like 100 square feet or even 70 square feet, and the height of that specific toilet area is around like 10 feet. So how to calculate the value? So here I'm considering 5 ACPH. So 5 into volume. Volume means what? Now I told you now the area. How much the area was? What is the area?
100 into 10.
70 into 10 into ACPH 5, 3,500 divided by 60. That's like 58.3. That means actual the CFM of that area should be around like 58 CFM itself, isn't it? That's a very small value. You're getting my idea, isn't it? So according to the CFM, you can place the fan. That means, according to the flow rates, you can choose the fan right inside for those arrangements. Okay. You got the idea, guys?
Sir, ACPH is always எப்பவுமே ஆஷரி பேஸ் பண்ணி தான் போகணுமா சார்?
Exactly, exactly,
லார்ஜர்
exactly.
ஏரியாஸ்க்கு
Especially for this kind of
லார்ஜ்
yeah, that's it. That's it. Normally for office areas, they will consider like 1, 2 something. But for this domestic restrooms, when it comes to negative ventilation, you need to get over with those standards itself. Okay now.
வாட் அபவுட் லார்ஜ் வெரி லார்ஜ் ஆஃபீஸ் எப்படி
Whatever. Hey, no, it's not meant to be office area. I told you it's for domestic, like வீடு புரியுது உங்களுக்கு apartments homes,
இது வீடு சார் நான் ஜென்ரலா கேக்குறேன் இந்த ஆஃபீஸ் எப்படி
office area is different. That's what I'm going to say. Okay.
Projectல they mentioned already one.
Yeah,
If they
obviously
don't
they will
mention,
mention. They will mention. Yeah, definitely they will mention. Then otherwise we can simply calculate. Okay, fine. So when it comes to a commercial rooms, in commercial, we can't get over with a simple exhaust axial fans. Instead of that, you need to dedicatedly provide an exhaust duct system like this. That means lot of restrooms will be there across this commercial area, isn't it? So from each restroom, which means from each toilets, you need to take out a terminal, and these terminals are connected with those exhaust duct system itself. And in order to find out the CFM value for that entire area, it should be around like 10 to 20 ACPH. Okay, it's like 10 to 20 ACPH. That's it. So is the domestic concept and commercial concept is clear. For domestic application, we can simply go with a axial fan itself. But as in the case of this commercial aspect, you need to use duct system. So that's the difference. Okay, now I hope it's clear. Is there any doubts on this one? No, isn't it? Is it clear, guys? Is the restroom ventilation is clear? Once again, guys, we need to simply study the ACPH value. The other aspects are very simple. Okay, now. Next of all, it's about the kitchen aspect. So while considering the kitchen, especially for a domestic application, that means for an household application, here, once again, we will be going with the ACPH method, and the ACPH value that we need to consider, it's around like 5 to 10. But once again, while implementing the kitchen ventilation systems, even for a home or even for a commercial area, we might need to consider NFPA standard. So what do you mean by NFPA? National Fire Protection Association. That means, kitchen is a high potential place for fire. So while implementing the ventilation systems, you need to consider the NFPA 96 standard, which is for the fire potent area, isn't it? That's why we are getting with the NFPA 96 standard. You hop over to the firefighting study, you already seen this kind of standards, isn't it? That's what it is. And once again, guys, for domestic kitchen, we can simply use an exhaust axial fan, which is similar to that restroom. You've been like domestic restrooms. You've seen that arrangement now. So even for this domestic kitchens, you can go with the same method itself. But especially for commercial kitchens, the exhaust fan, which is the normal exhaust fans, won't be enough for that assemblies. Why? Because, you know, the comparison between the commercial kitchens and domestic kitchens, it's up to the usage of those area. Commercial kitchens will be frequently used. So probably, there is a chance of formation of tar-like material. So have you ever visited any roadside this kind of food shops like this chicken rice or something, chicken noodles? You've been seeing the actual arrangement of those fans, now the color of what was the fan color? Probably in Chennai, wherever I go, I've seen those fan colors should be normally in black color itself. Eventually the fan motor should be entirely covered with the oily contents. Why? Because they are cooking, isn't it? That's why. So that's why we are saying for commercial kitchens, we need to get over with some more advanced kind of technologies, which means it's not meant to be duct system. Instead of that, in order to prevent the fan damages right onto the area, we will be using a lot of concepts such as to be hoods. So the basic hood arrangement in homes, you've been seeing that one, which is anotherly named as to be chimney, isn't it? What is the purpose of chimney? To draw the air. Sorry, to what you can say? Yeah, to eliminate the smoke from the area by advising these smoke right onto the chimney itself, isn't it? It's meant to be a natural draft. So I will explain natural draft and forced draft. Natural draft means there won't be any fans. It should be naturally going. Like hot air will always go to the top side itself, likewise. So that's what I'm saying right here itself. In commercial kitchens, we are using hoods for ventilation to capture the smoke from the point of its origin itself. So once again, there are two types of hoods are available. First one is a type 1 hood and type 2 hoods. Type 1 hood, which implies it should be used to capture the oily content air. That means inside this oily content air, you'll be having a separate oil trap will be there. So along with the air, you can trap out the oils right from the exiting air itself. So Once again, the type 1 having an oil trap and it is used across the frying areas, the frying barbecue in that areas or in this even for this grills. In those specialized area, you can use this kind of type 1 hood. And type 2 hood are used especially on, you will be having hot steam and wet steam areas. Okay, now it's like boiling areas, like a rice boiling area, cooking area. Especially what I'm saying is like the boilings, that's it, what I'm saying. So that's it. Then once again, this type 1 hood is again classified into two. Has to be canopy hood and proximity hood. Canopy hood, which means it doesn't have any fan. Okay, now that means it's like a natural convention method itself. As in the case of proximity hood, it should be attached with a fan arrangement itself. Once again, for type 2 arrangement, it is again further classified into two types like condensate hood and oven hood. Condensate hood, which means it have baffles to trap out the water vapor and condense back into water droplets. Okay, that's you can see these baffles which will condense the excess steam back into water. And as in the case of oven hood, it's like a constant normal one. It doesn't have any baffles. Now let's hop over to the canopy hood arrangement and proximity hood arrangement. Let's check on to the canopy hoods. So I told you canopy hoods will be overhanging the cooking equipment, which means it should be placed on top of the stove or the cooking equipment, the stove. That's what I was saying. And here the air velocity is very low due to natural draft. Natural draft means these hot air should be gradually flown across to the top side of that canopy hoods itself. And these are the types of canopy hoods. And as in the case of proximity hoods, it should be underhanging. So what do you mean by underhanging? Is it should be placed at the bottom of the stove? No, not like that. It should be placed on the side of the cooking equipment. Here, the velocity of the air is too high, which is meant to be you having a fan. That's why. Okay, so you can see the difference. These three are meant to be the canopy hoods. You can see this now. It is connected on the top side of the cooking equipment. And you can see a small connection here itself. Now, this is the portion that you will be connecting your ducting if it is needed. Definitely, you will be having a ducting gap. That's it. And this is the eyebrow. Sorry, these three you can see this now. Eyebrow, hood and passover proximity hood, backshell proximity hood. These three are meant to be the proximity hood types and these three are meant to be the canopy hood types. All right, fine. Hello, is it clear, guys? Hello, is it clear? All right.
Yes.
Yeah, okay, fine. So in type 2 hoods, you can see this is the condensate hood and this is the oven hood. Normally, condensate hoods, I told you now, it should be used to take out the excess steam which escaping through the air itself. So you will be having some kind of baffles like this. Okay, and these water should be eventually trapped out with the help of this uh, water trap right on the side itself, or even at the other ends of the condensate hood right there itself. Later, it's about the oven hoods. So normally oven hoods are used, especially even commercial or domestic. It's up to the user and requirement itself. Okay, so you know the concept of oven hoods. It will draw the air directly. That's it. So these are the concept of this two different things. And next of all, it's about the basement ventilation. So generally, once again, guys, here, did you studied about the ACPH value for kitchen ventilation, especially for commercial kitchens, the values in between 20 to 25, sorry, 10 to 25. Okay, 10 to 25 ACPH. It's up to the, the occupancy and the area itself. You can increase the value if the area is too high. All right. So this is for domestic kitchen. For commercial kitchen, the value should be around like 15 to 20 ACPH. That's it. Or 25. It's up to the areas. Later, it's about the basement ventilation. Generally, there are three different methods are there. The first method, which prefers comparatively for smaller basements, which you can see this now. For a single basement, we can use this kind of arrangement. That means there will be two fans. One should be supplying fresh air and the other should be exhausting the stale air. And here, there won't be any ducts. It's purely adopted in case for smaller basement application itself. Okay. Once again, guys, Just consider a building having a basement on the ground floor. Is the ground floor basement need any ventilation? Tell me, guys, is the ground floor basements or the ground floor car parking need any kind of ventilation?
Not required.
Yeah, exactly. Why? Because it's already contacted with the atmosphere itself. So probably
Yes,
there
yes.
should be an infiltration will happens. Okay. So when we need ventilation, it's when it comes to basements. Okay. For smaller basements, you can use the method one. And the same concept, guys, if you're having comparatively bigger basements, these two fans will be attaching with two duct system like this way. That means one for fresh air and the other one for exhaust air. That's it. Clear? You got the difference, isn't it? Hello, is it clear? But guys, actually, if you are implementing two different duct system like this way, like exhaust ducting and fresh air ducting, the cost should be comparatively high, isn't it? In those scenarios, for much more controlling and other aspects, you can adopt some different kind of concepts. So that is meant to be the method three. Here also, there will be two main centrifugal fans will be there in order to supply the supply air and to draw out the exhaust air. Okay, so how it's done? For that one, I'm going to show a simple arrangement like this. So let's consider this is the basement, okay? It's white, isn't it? Sorry. So this is the basement, guys. Let's consider this is the basement. I know these basements are stacked up like this way, isn't it? These basements are stacked like this way. Okay, now. So whatever. And however, there should be a vertical shaft will be going like this. Okay, now. What is it? A vertical shaft means a hollow shaft area. What is the purpose of hollow shaft area? The here you'll be having this fans. So on top of, for once again, sorry, here you can see three different basements are there. Basement one, basement two, basement three. In order to provide the fresh air for the basement three, I definitely need a shaft area. It's just a hollow space, guys. Okay. So on top of this shaft area, you will be connecting a centrifugal, and these fan will supply the fresh air through this way. Okay. This fresh air, sorry, this shaft area will provide the fresh air across the shaft area like this. And you will be having an another fan. It should be placed at the other shaft end, used to remove the exhaust air to atmosphere. Okay. So it should be like this. Okay now. So this is for the exhaust and this is for the, so this is meant to be exhaust and this is meant to be the fresh air. Okay. So how this should be going? So this is how they stacked up. Once again, once these fresh air are getting entered into those respective basements, now how these fresh air should uh, spread across that area. For that purpose, I'm gonna show some kind of arrangements, which is meant to be jet fan assembly. What is it? Jet fan assembly. So these are used in order to avoid the cost of ducting. Okay, now. So generally, this kind of jet fans are placed in an arrangement like this way. So it is meant to be according to the, sorry, these fans are arranged like this way. Okay, now. Yeah, likewise. So these jet fans in this picture, you can see this now. This is meant to be the jet fans. Jet fans are placed across the basements according to the zonal concept. That means, for each area, it should be considered as some kind of zones. So as if I told you right now itself, now the fresh air should be entering to the area, should flow across the area. Actually, these jet fans are equipped with two sides. The one side should be the suction side, and the other side should be act as the discharge side. Okay. So here, what will be actually happening? It should draw the air at a certain extent, and it should discharge the air approximately a distance of 30 to 40 feet distance. On the exact same extent, you will be having the other jet fan. So this is how they will spread the fresh air. At the same time, the existing air gradually sucked over through the way itself, and it should be reverted back to atmosphere once again. It's okay. So this is the concept of a jet fan assembly right here itself. So normally, if you consider a commercial area, we can avoid the duct costing right here itself by implementing this kind of jet fans. Normally, guys, here we don't need to subject these fans to operate at full loads. Why? Because, if you consider an area, probably it having peak hours and non-peak hours. For example, a commercial building, that means a shopping complex area. At evening times, probably the number of persons should be comparatively high at that time, isn't it? So how these fans will know they having a lot of automobiles right inside the area? That's why we will be placing a CO sensors, this carbon monoxide sensor. Whenever the emissions are too high, it means to be that should be a peak hour concept, isn't it? Whenever the carbon monoxide sensors indicates it has to be too much emissions, that means a lot of cars or a lot of automobiles are right inside that area. So this is I told you guys, it is meant to be the zonal concept. Okay, so this is meant to be zone 1. Zone 1, zone 2, zone 3. So according to zonal concepts, you'll be getting the feedbacks. So for peak hours, the fans will be working at full speeds. But as in the case of non-peak hours, the fans should be operated at low speeds itself with the help of a VFD panel arrangement. That's why here you can see something attached right here itself. Now, this is the IQ boards, which means the PLC boards for the entire fans. And these feedbacks, actually the CO sensor is not placed on the fan. Instead of that, it should be placed on the beams. That means the columns. Okay, now that's it. So especially for high commercial buildings, and like if the client is too wealthy, they will be going with this kind of jet fan assembly right there itself. Okay. So once again, for peak hours, the value is around like 20 to 30 ACPH. That means for 20 to 30 ACPH, you will be getting a defined CFM value, isn't it? For non-peak hours, the value is 5 to 10. So by considering this 5 to 10 ACPH value, you'll be getting another CFM value. So this is the two speeds of the fan right there itself. For example, at the case of 30 ACPH, you got it has to be 800 CFM. But in non-peak hours, according to those ACPH value, you got around like 400 CFM. So you can see the difference, isn't it? So according to the CFM, you can provide the velocity, or sorry, you can adjust the velocity at the same time. You can adjust the fan motor speeds according to the loads right there itself. Okay. So is it clear?
சார் ஃப்ரெஷ்ஷர் உள்ள எப்படி வரும் சார்? லைக் யூசிங் ஷாஃப்ட் உள்ள வரும்னு சொன்னீங்க.
That I told you na. In the each
உள்ள
extreme of
டக்ட் ஏதோ இருக்குமா சார்?
இல்ல இருக்காது. அது வந்து எக்ஸாக்ட்லி கனெக்டட். ஒரு ஷாஃப்ட் மாதிரி எல்லா ஃப்ளோர்லயும் ஓப்பனிங் கொடுத்துருப்பாங்க. தட்ஸ் இட். சொல்றது புரியுதா? ஒரு வெர்டிக்கல் ஷாஃப்ட் இருக்கும். அது இந்த எல்லா பேஸ்மெண்ட்ஸையும் கனெக்ட் பண்ணும். அது ரெண்டில் நீங்க என்ன இருக்கு உங்களுக்கு? That I told you. One side
Okay, sir. ஏதாவது ஃபேன் த்ரூ ஃபேன்
exactly you will be yeah, that's I told you. Initially you will be equipped with two centrifugal fans, one for supply and one for return. Between exhaust. Beyond that, you will be having individual jet fans right inside the entire car parking area. Okay. So especially in Middle Eastern countries, they will be adapting this kind of jet fan as we right there itself. Okay. So is there any doubts, guys? No, isn't it? Fine. So we will continue with the tomorrow session. Okay. Now we can leave. Okay, yes. Bye.